This resource is the first in a multi-part series that considers a number of topics in trigonometry. Part 1 looks at radians, defining this alternate method for measuring angles and providing methods for converting back and forth between degrees and radians. Part 2 focuses on right triangle trigonometry, looking at the 6 trigonometric ratios. It also looks at the identities that define the other ratios in terms of sine and cosine. Part 3 explores the connections between trigonometry and the Cartesian plane. Part 4 considers the inverse trigonometric functions, used for finding angles when the ratios are known. Radians are an alternate method for measuring angles. But what exactly is a radian? Consider a circle with some radius, the length of which we will call r. Now, suppose two radii are drawn in our circle to form an angle. If the length of the intercepted arc, the section of the circle that the angle would cut out, is also r, then the angle has a measure of exactly 1 radian. We can use the definition of radians to compare the length of an intercepted arc, the length of the radius, and the measure of the central angle formed by the radii. The central angle, which we will denote as the Greek letter theta, is equal to the ratio of the length of the intercepted arc and the length of the radius. For example, suppose a central angle in a circle creates an intercepted arc of length 10 centimeters. If the radius of the circle is 4 centimeters, what is the measure of the central angle in radians? We have our formula for finding the measure of the central angle given the two lengths. Plug in the information that we know, that the length of the intercepted arc is 10 centimeters and the length of the radius is 4 centimeters. Dividing, we find that the measure of the central angle, theta, is 2.5. Note that the centimeters canceled out. Radians are dimensionless, that is, they are just a number with no associated units. Of course, most people are much more accustomed to using degrees to measure angles. How exactly are degrees and radians related? Consider a circle with only one radius drawn. In other words, that radius creates an intercepted arc that is the entire circumference of the circle. Therefore, the intercepted arc length is equal to the circumference, which can be calculated as 2 times pi times the length of the radius. To find the measure of the central angle, we divide the length of the intercepted arc, 2 pi r, by the length of the radius, r. This simplifies to 2 pi. If we think about the degree measure of the central angle, it completes an entire rotation around the circle. It has a measure of 360 degrees. We can set the two different methods for measuring the central angle equal to each other. We have 2 pi radians equal to 360 degrees. We can simplify this by dividing 2 into each side of the equation. This leaves us with the relationship that pi radians equals 180 degrees. It is important to note that pi is part of the radian measure. Most angles are written in terms of pi when expressed in radian measure. Once we have this relationship, we can set up a ratio that allows us to convert between radians and degrees. To convert from degrees into radians, multiply the measure by pi divided by 180 degrees. For example, suppose we want to convert 45 degrees into radian measure. We multiply the 45 degrees by pi over 180 degrees. So we have 45 degrees times pi over 180 degrees. We can simplify this fraction to pi over 4. Note that the degrees cancel out, and we are just left with a number answer. Converting from radians to degrees means to take the pi out and put in degrees. We multiply by 180 degrees and divide by pi. Suppose we want to convert pi over 5 radians to degrees. Multiply by 180 degrees over pi. So we have pi times 180 degrees in the numerator and 5 times pi in the denominator. We cancel what we can. The pi's cancel, and divide the 180 by 5, leaving us with an answer of 36 degrees.